Okay, good evening. This is Professor David J. De Los Reyes. Okay, the date for today is October 24, 2023, and the time is 9:35 p.m. Okay, my topic for tonight will be trigonometry. I have discussed already the concepts regarding angles on the study of trigonometry and the concepts on how to determine the value and signs of the different trigonometric function. So for tonight, I will be discussing example problems on the applications of those concepts. Okay, let's proceed. The subject matter for tonight will be trigonometry, lesson number 9. We are now on lesson number 9 and we are running smooth on the study of trigonometry. The title of the topic for tonight will be example problem on angles. Okay, angles and the other definition of trigonometric functions. But the concentration for tonight will be example problem on angles. Okay, I will try to give you example problems, 2 example problems on angles. This will be example number 1, and this will be example number 2. They are just an easy ones. We'll just apply our knowledge on the so-called definition of trigo functions, if we could recall it. Okay, I will try to read the problem. Number 1. If a vertical force subtends an angle of 13 degrees 15 minutes from a point on the ground 76 feet away, how high is the force? We are given a force in a certain time of the day. This force here, okay, form an angle subtends. Sorry for that one. Subtends. The other meaning of this is formed. Form an angle of 30 degrees 15 minutes. Meaning this force here form an angle with respect to the horizontal ground, horizontal. The magnitude of the angle is 13 degrees 15 minutes. From a point on the ground 76 away, how high is the force? Meaning the angle where this ray here intersects the ground is actually 76 feet away. 76 feet away meaning its distance from the bottom of the force is 76 feet away, 76 feet. So if the angle subtended by the force at a certain time of the day is 13 degrees 15 minutes, okay, 76 feet away from the force, okay, how high is the force? How high is the force? Meaning this 13 degrees 15 minutes is actually 70 feet away from the vertical force. So if we try to draw there should be a right triangle that will come out. This will be the force. This is 76 feet away. And the angle subtended is 13 degrees 15 minutes. And this is the height of the force at a certain time of the day. Right? So at a certain time of the day, of course, there should be a ray of the sun pointing to this point here, and this point here subtends an angle with respect to the horizontal ground of 13 degrees 15 minutes. The problem is just asking how high is the force. So this will be an application of trigonometry. We'll try to bring out the right triangle. The right triangle will be this one, right? This vertical height here is h, the unknown force, the unknown height of the force, right? It is this. Okay, this is vertical and this is horizontal, and this should be the hypotenuse. A horizontal and vertical meaning the angle between the horizontal and the height of the force should be 90 degrees. So this refers to the study of a triangle in which the inside angles are actually acute, meaning the sum of this angle here plus this angle is actually 90 degrees. So it falls under our topic, right? So if we now try to bring out this triangle here, it is actually this. This is 76 feet, right? 76 feet. This is the fosse. It is erected vertically, and this is the horizontal ground. The distance 76 feet is the horizontal ground. This is h, and the angle formed with respect to the sun is 13 degrees, 15 minutes. So this is 13.25 degrees. So we are given this side here. This is the unknown, and we are given this angle. So to solve for h, we apply our knowledge of the so-called basic definition of trigo functions. What function we will be using over here? This side here and this side, what's the relation? It's either tangent or cotangent, right? If considering this angle here, this is opposite side, this is adjacent side. And if we try to take the relation of h with respect to the other given values, we will be using the definition of tangent. Tangent is actually opposite side over adjacent side. So if we try to take the tangent of 13 degrees, 13.25 degrees, it should be h all over 76, right? So this is h over 76. So we are now applying our knowledge on the so-called definition of trigo functions to solve this problem, okay? Because trigonometry solve our real problems in real life, right? Like the determination of the height of this post. You don't have to climb the height of the post and measure it to measure its height. We will just use our knowledge of trigonometry to solve for the height. So solving for the height now, the height will be, it seems this is all over 1, right? Then we try to cross multiply. So h times 1 will be h, and tangent of 13.25 times 76 will be 76 times tangent of 13.25 degrees. So this should be 76, tangent of 13.25, the angle is less than 45, so the value of the tangent is less than 1, and it is 0.23546. Multiplying this one, the height of the fosse is 16.895 feet. It's almost 17 feet. It's almost 17 feet. 17 feet, 76 feet, it's like this. Almost 16.895 feet. This is 76 feet. And this is 13.25 degrees. Okay. So that's the solution of the problem. The unknown height of the fosse is 16.895 feet. And the solution we brought out is actually the definition of the tangent function. Okay. We apply our knowledge on the so-called definition of tangent function. Tangent is the ratio of the opposite side over adjacent side, considering this angle here. It is this. Okay, example number 2. So those are easy ones. It is just a matter of applying our knowledge of the so-called definition of trigo functions. Okay. Example number 2. Find the side of a regular decagon inscribed in a circle of radius 8 feet. The word decagon over here. So this should be a many-sided figure, and the radius of the decagon is 8 feet. So it seems we are given a picture, right? And the picture was sliced into 10 pieces, because decagon, if we try to define what's decagon, it's actually a many-sided figure of 10 sides, right? So it seems we are given a picture and we slice it 10 times. Okay, one slice, one component is one slice. It's the total slices will be 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. The problem is just asking find the side of the decagon. The side of the decagon is this one. It is this. That's one side. It is not drawn to scale. This is one side, another side, another side. So going around, it's 10 sides, right? 10 sides. So the problem is asking what will be the length of this side here if the radius of the decagon is 8 feet. The radius here is 8 feet, right? So the key to the solution of this one is just we use symmetry. We just bring out one slice. One slice will be this one. It is something like this, right? That's one slice, right? And if we try to drop a perpendicular line over here, perpendicular line, it is this. This one is actually the total side of the decagon. So if we try to slice this one into two equally, right? This length here should be s over 2. And the other half will be s over 2. It is symmetrical, right? We cut it in half. So if we cut this side here in half, of course the angle here, we cut it also in half. And what will be the angle per slice? What will be the angle? Going around, it's 360 degrees, and there are actually 10 slices. So 360 degrees divided by 10 will be 36 degrees. So the included angle between each slice is actually 36 degrees, right? 36. And if we cut this in half, this portion here will be 18 degrees. Okay? Just take one half. We erase one half. Okay? We erase one half. Okay? Then we try to enlarge this one. It is this. Right? This is 18 degrees. This is actually the radius of the decagon. And this portion here is s over 2 because we cut it in half. So this is s over 2. Okay? So the key to the solution of the problem is still trigonometry. Right? So it seems we are now given a right triangle. This portion here is perpendicular, right? So actually this is a right triangle. If we try to put it horizontally, this is horizontal, this is vertical. So this is actually 90 degrees. And this angle here is 80 degrees. This is 18 degrees. And this length here is the radius of the decagon, it's 8 feet. And this portion here is actually s over 2. Right? So from the resulting figure, the only unknown is s. We are given the hypotenuse. We are given this angle here. Am I still on the camera? Right. We are given this angle. Okay. We are given the hypotenuse to be 8 feet. This portion here is designated s over 2. So to bring out the equation on how to solve for s, just think of the relation of the opposite side in adjacent side. It should be the sine function. Sine function is actually opposite side over hypotenuse. Considering 18 degrees, this is opposite side. So if we try to take the sine of this, it should be this side here, all over 8 feet. Oh, that's the definition from our definition of the concept, right? So sine of 18 degrees will be s over 2, which is the opposite side, s over 2 over 8. Rearranging or simplifying the right hand side, it will be s over 2. Okay, we change the operation from division to multiplication. We will take the reciprocal of this times 1/8. Simplifying this one, s times 1 will just be simply s. Right? And 2 times 8 will be 16. And this should be equal to sine of 18 degrees. So if we try to solve for s will be 16 times sine of 18 degrees. It is 16 sine of 18 degrees. 16 times 0.30901. Sine of 18 degrees, it's a value less than 1. 0.30901 times 16. And the value of s will be 4.94. So this side here is 4.94 feet. Okay. That's a decagon. It's actually a circle. It's a many-sided figure inscribed in a circle, and the total number of sides is actually 10. So one angle inside is 36 degrees, and there are 10 pieces, so it will be one complete revolution is 360 degrees. So the key to the solution is the computation of the included angle inside. If you made a mistake on the angle here, you're wrong. Because there are 10 pieces here, 36 times 10, it will be 360 degrees. So one complete revolution to complete the decagon. Okay? So the included angle should be 36 degrees. And again, we slice it into, this is perpendicular, it will come out like this. So 1/2 of 36 will be 18. The included angle inside now will be 18. So in the computation for the unknown value of S, we will be using 18 degrees. It is not 36 degrees, right? It should be 18. So the value of S will be 4.94 feet. Okay, that's it, guys. This is how to solve problems under trigonometry by applying our knowledge of the concepts of the definitions of trigonometry. Okay, good evening from Los Angeles, Professor Rebecca.